Hello and welcome back. The following question states a sample of argon gas that originally occupies 14.6 liters at 25 degrees Celsius was heated to 50.0 degrees Celsius at constant pressure. What is its new volume? So we know we are looking at an increase in temperature and we have to find its new volume. So they give us our initial volume and our initial temperature, and they give us our final temperature, and we have to find that final volume. We know this is Charles's law, which states that volume is directly proportional to temperature. So as one increases, the other must increase in order to keep pressure constant and the number of moles constant. So let's go ahead and write out his equation. And we know we're solving for our final volume, so let's go ahead and rearrange this equation in order to solve for it. So our final equation is going to be our final volume is equal to our initial volume multiplied by our final temperature divided by our initial temperature. However, before we can continue on, there's something else that we have to do before we can actually plug in our values. We have to convert these temperatures in degrees Celsius to Kelvin. Remember, temperature in Kelvin is equal to your temperature in degrees Celsius plus 273.15 to get your answer in Kelvin. So let's go ahead and do that, and let's plug in our values into the following problem. So our initial volume is 14.6 liters. If we take our final volume and we add 273.15 Kelvin to that, it will be 323.15 Kelvin. And then our initial temperature would be 298.15 Kelvin. Kelvin and Kelvin cancels out, and our final volume is going to be equal to 15.8 liters. Let's go ahead and check this question, check our final answer to make sure it makes sense with making sure that volume and temperature are directly proportional to one another. We increased our temperature, so our final volume must be larger than our initial volume, which holds true. If our initial volume is 14.6 liters, our final volume is now 15.8 liters. This increase in volume was expected, and so our answer makes sense. Make sure when you do these types of problems, you're walking through and making sure your final answer makes sense to what it should be. Thank you.